In this video, we will discuss about finite automata, types of finite automata with an example. Definition of finite automata. A finite automata is a simple idealized machine used to recognize patterns within input taken from some character set or alphabet C. The job of an FA is to accept or reject an input depending on whether the pattern defined by the finite automata occurs in the input. It accepts regular language and regular grammar.
Formal definition of finite automata. Machines equal to Q, sigma, del, Q naught, F, where Q is finite set of state and sigma is finite set of input symbols and del is transition function, Q naught is start state of finite automata and F is finite set of automata. Types of finite automata, that is deterministic finite automata and non-deterministic finite automata.
Deterministic finite automata. A deterministic finite automata or DFA is an abstract machine whose behavior can be described using a transition diagram like this one. These nodes in a diagram indicate the states of a machine and the edges indicate the state transition that occur when the machine reads the next symbol in the string. Non-deterministic finite automata. In a non-deterministic finite automata, for each state there can be 0, 1, 2 or more transition corresponding to a particular symbol. If NFA gets a state with more than one possible transition corresponding to the input symbol, we say it branches.
Let us see an example to construct a DFA using automata stimulator. The question is the automata which accepts all strings over the input of sigma equal to 0, 1 starting with string 0, 1. The solution is let the language accept the automata be language equal to a set of strings. Let's see how to construct the automata.
In Automata Simulator, check whether the automata is in DFA. As we are going to construct a DFA, we need to keep the automata in DFA. First, there is a default start symbol. Next, add the states. We have two inputs, so the maximum number of states we can produce is 3. So, I'm replacing all the states and we are going to give an input symbol. First input is 0 and next input is 1. Arrange the automata. Now we need to set the final state. Our final state is S1. Now check the first input 0, 1. It is accepted by the automata. Next input is 0, 1, 0. So the final state should loop itself for 0. Next, the 0, 1, 0 is accepted by the automata. Next, we need to self loop 1. Then the input is accepted by the automata. Next, it will accept all the inputs as be given in the language. Let's check 0, 1, 1, 1. It is all accepted by the language. Hence, in DFA, every symbols should get input by get in all its input. So here 0 is an input, then 1 is self looped. And in S1, 1 is given as an input, then 0 is self looped. Hence, this is the final automata and it accepts all the language that we have given into it. To step by step of the automata, the start symbol is 0 and it is accepted by the automata. Enter. The second symbol is 1. It is accepted by the automata. Third symbol is 1 and it is self-looped and it also accepted by the automata. And the fourth symbol 1 is also accepted by the automata. And all the symbols are accepted by the automata. And this is the DFA for the given language.
Hope you all understand the concept of finite automata. Thank you for listening the video. Thank you.